Let's take a look at the following. Let's say that we were in section 4.2 and we wanted to go from logarithmic form to exponential form. Let's just review that a little bit, and then we're going to focus on evaluating logarithmic expressions. Okay. So let's say we had to go from one form to the other. Let me just remind you that we have the following right here. If I have y, let me see. So if I have y is log base b of x, this is log form. If we want to go from this form to the exponential form, which is going to say b raised to the y is equal to x, let's just review how this goes. Let me start with y is log base b of x. If you wanted to rewrite it, since you're going from log form to exponential form, I like to swap both sides and have log base b of x is y. And you remember the idea of zapping a log. What I'll do a z through the log. I'll grab the base, push it to the other side, and then what do I see after I zap the log? What do I have? I will have over here all of this gone, so I'll just get that x is equal to, notice, b raised to the power y, which is exactly what this form is if I were to swap both sides. So the easiest way, I believe, to go from log form to exponential form is to zap the log. What do we call zap the log? Now, let me just grab an example just to review with you. Let's say we wanted to go from logarithmic form to exponential form. What we can do, let's just grab an example here and see what we have. Let's say I had this example right here. If I have number 2, which says that 6, we have over here that in number 2, the log form is 6 is log base 2 of 64. Let me just swap both sides and show the log first. So I have log base 2 of 64 is 6. Let me zap the log and carry over to the other side the base. So on the left hand side everything is gone except the 64, and that 64 is equal to 2 raised to the power 6, and that would be the exponential form, having started with the log form above. And that's what we have for this one. And notice that 2 raised to the 6, which is 2 times 2 times 2 times 2 times 2 times 2. So 2 times itself 6 times is indeed a 64, because 2 times itself 3 times is a 8. 2 times itself 3 times the 8 as well, so that's a 64. So really what they're saying here is really true and making sense if you think about it. Now let's take a look at another example where we're going to go from exponential form back to log form, in which case we will not zap anything, we will just think about what everything means. So I'm going to do another example with you in just a second. So let's say in this particular question we want to go from exponential form to log form. How do I know I'm starting with exponential form? Because I have the base 2 raised to the power negative 4 is equal to some number. So you don't see the word log anywhere, and you're really expressing a base to an exponent raised to an exponent is equal to a quantity, in this case 1 over 16. So let's go ahead and identify for this one all the pieces that I have. Let's notice that I have a base which is over here 2. So 2 is a base. the quantity being raised to the power. Now, what is the exponent? The exponent is -4. And I have 1 over 16, which is the other quantity. So to go from exponential form to log form, you just have to start writing what the log is about. We'll have for the log form that it's log, and the base will go right here. Log base whatever of something is equal to something. So that's how we do that. And let's just recall also the little saying that a log is nothing else than an exponent. We need that information. Okay, so let's go ahead and do the following. Let's fill in the information. The base, which is right here, hanging from the letter G, should be 2. So that goes right here, the 2. Now, let's see what else we got. We know that a log is what? An exponent. So I do see a log base 2 of something which I haven't put in yet is equal to, the quantity on the right. So a log is what? Is equal to an exponent. So the exponent should go on the right hand side. And then what I should do is the following. I should put inside the log the quantity I haven't used yet, which is 1 over 16. And then that would be the answer to that question. And I know I have a lot of information written everywhere. Let me just clean it up a little. And that's the way the final answer would look. Now you may say, how do I know it's correct? All you have to do is take that log base 2 of 1 over 16, which is equal to -4, and just zap your log and see if both sides are matching. So let me see that with you. Is it true in life that 1 over 16 is equal to 2 raised to the power -4? So let me just check that out with you. You could do it two ways. You could start with the right hand side and show that it is equal to the left hand side by just swapping both sides. You can start with 2 to the -4. What does that mean? This is 2 to the -4 over 1. So you could bring down the 2 to the -4 in the denominator. Remember, things can move up and down that fraction bar as long as you change this exponent to its opposite, which we did. It's 2 raised to the power plus 2. Let me say that again. 2 raised to the power plus 4, which you just call 2 to the 4th. Okay. So it's just 2 to the 4th over here. Let me just erase that little plus sign. I lost my 2 in the process, so really the 2 to the -4 goes down in the denominator as 2 to the 4th. Let me write that very clearly so we can see we have a base 2 raised to an exponent 4. Now what happens? The numerator is empty because the 2 to the -4 moved down, so you always need a 1 to hold the spot of the numerator. So this is 1 over 2 times itself 4 times. 2 times 2 is 4, times another 2 is 8, times one more 2 is 16. So it's indeed 1 over 16. So that checks that this relationship is true indeed. So we did do a lot of work here, but really all they wanted is to go from exponential form to log form. And I did check, by zapping the log that we recovered what we had on the right hand side, what we started with, and then I proved to you that what they were saying right here was indeed something that made sense.